Hey guys, welcome to Chapter 3. Now we're going to get into the heart of the course, really, and where we start to consider the issues of statistical inference. Chapter 3 will look at confidence intervals, and Chapter 4 will focus on tests of significance. Those are two types of inference. So, to get at that idea, well, let's look at a few questions first, and I'd like to go through a diagram, try to visualize what we're doing. Chapter 3 starts with a little bit of an outline, so we're going to focus on sampling distributions today, and then move on to the focus on the confidence intervals and a method for computing them a little bit later on. So I thought they'd do a good job in starting with some real application-based questions here at the beginning of this section. Do they really pay you to go to graduate school in statistics? That's sort of a yes or no question. What proportion of U.S. residents have a college degree? Or in this environment, we might ask what proportion would test positive for the COVID-19 at any particular day. But then we can also, that's categorical. Then what is the average number of calls per day by cell phone users? That's a question about a quantitative variable and about an average as opposed to a proportion. If we look down here a little bit further, we see sort of differences. There's a study of rats and whether rats are compassionate, and asks whether female rats are more compassionate than male rats. Here's an experiment whether drinking tea helps the immune system. So that might be a quantitative or categorical response, but we're looking at relationships in this case. How often on average do people laugh? And then let's see, are consumers willing to pay more for socially responsible products? So sometimes we're really considering differences in proportions, sometimes differences in means, but in some way we're trying to make inference about something that we're going to consider to be a parameter. So let's go over and take a look at the basic figure that we think about when we're thinking about inference. So remember, here's our population. And in the population, we have parameters, which are facts about the population, mu, sigma, p. And in fact, with that, I'm starting to get into some of the notes of this section on sampling distributions, parameters and statistics. A parameter is the number that describes some aspect of a population. A statistic is something that's computed from data in a sample. So now down here, down here we have some sample of the population, and we'd like to think that that sample resembles the population. We drew it, and we're going to consider that we drew it via random sampling. So, for these values up here, we could compute corresponding statistics, which are estimates of those parameters. X bar could estimate mu. P hat could estimate the population proportion P, and so on. Now, once we've got these estimates, the challenge is to go back to the population and make inference. So this idea of statistical inference is all about how do we do that? What are the methods and what's the justification for doing that? And two kinds of inference I want you to be thinking about, or that we're going to consider, are confidence intervals, and then the other, which we'll get to in Chapter 4, is hypothesis tests, or we could call that tests of significance. We're trying to see if the data give evidence to support a claim or to refute a claim. So really the idea of the scientific method there. Now with this section, as we're getting into sampling distributions, what we're going to be considering is the idea of sampling from a population. So here's our population, and we're going to consider what happens if we drew samples repeatedly. That is, not in practice that we would actually do this, but if we understand how these values would vary, we get a sample mean, we draw another sample, get a sample mean, another sample. If we can understand how these things vary from sample to sample, that's going to help us make this leap from the sample back up to the population to generalize about the population. So that's going to be our goal in this section. So let's get started. And to get started, I want to take you to the lesson for this page. The section 3.1 class lesson. When you see this, it'll look something like this. May be a few more things filled in. But one of the things is the section 3.1 examples. So let's walk through that a little bit together. If we're all together at once, we could work through this a bit systematically. I'm going to work through it kind of back and forth and talk about a few topics as we go. But let's take a look. If we're looking for health information online, in a Pew Research Center survey of a random sample of 1,931 adult users, 1,120 said the internet had helped them in some way with obtaining health information. So find the relevant proportion and give correct notation with it. Well, what relevant proportion? Well, it looks like we're looking at 1,120 out of 1,931. That's the proportion that we're going to label as p hat, because this is a statistic. It's something generated from a sample, and it's the proportion of internet users who said that the internet had helped them in some way with obtaining health information. It might be quite a bit higher even now. Give notation for and define the population parameter that we estimate. So the notation would be p, and we could denote that as being the proportion of all U.S. adult internet users who say that the internet has helped them in some way obtain health information. Okay? So that's what P would represent, and then we have a corresponding statistic. All right? Now let's take one more example here while we're here, and then maybe we'll take a look at a quick self-quiz, self-check. So next is a survey of 2,986 Americans aged 16 and older found that 80% read at least one book in the last year. Of these book readers, the mean number of books read in the last year is 17. We'll call that X bar because this is from a survey. Well, the median of books read in the last year is 8. We can call that M if we like. So how many book readers were included in the sample? Well, 80% read at least one book. So if we take our 0.8 times 2986, we multiply that out. So 0.8 times 2986, we get, oops, I did it again, 0.8 times 2986. So 2389, we'll round that off. So 2389. All right, so that's the number of book readers. Why might the mean and median be so different? Well, I hope you can picture the distribution. Looks like we probably get a lot of people who read 0. Well, 20% read 0. And then they're the number who's read just a couple books. And then you probably have a skewed distribution there, don't you? So a few people reading a lot of books are going to pull the mean number up to 17 while the median is at 8. So using the information given, what's the likely shape of the distribution? So we think it would be skewed right. Now, why does this question come up here? Well, it's to make sure that we're still thinking about data. Even though we're going to be thinking about inference, still want to think about the nature of the data. And that's going to be really important as we move forward, because we want to think about what does the sample look like, what does the population look like, and hence what methods are going to be warranted in a case like that. So give the correct notation for the value 17. Oops, did that already. Is this value a parameter or a statistic? Well, it's from the sample, so it's going to be a statistic. Now you should pause before each part when I do these worksheets, and I will occasionally, I think, a little bit more as we get into some of the substance of this. So make sure that you kind of try it on your own, and you should be able to access those and do that on your own. But let's see, give notation for and define the population parameter we estimate. So the notation is mu. It's a mean. But mean of what? So I have to be a little bit careful here. And this is one that I would suggest that you take a look at before I go ahead and write it down. Alright, so assuming that you've done that, what we want to note is that this is going to be the mean number of books. So mu represents the mean, the mean number of books read by all Americans 16 and older? No, by all Americans 16 and older who read at least one book in the last year. So that's our population. You might say who reported reading at least one book in the last year. Whether they actually did might be another question, but we'll kind of sweep that under the rug for now. Okay, so now let's move on to the next, this quiz, and I'm going to have you pause and take a look at it. I would suggest you try to do this on your own. For each one, state whether the quantity described is a parameter or statistic, and give the correct notation. Okay, I hope you gave that a try. The proportion of all residents in a county who smoke. Proportion is P. All residents means that we're talking about everybody, so that's a population. If we were somehow using this county as a sample from the state or from the country, first that would be a dubious thing to do. It's just hard to imagine that it would really be representative. But in that case, then I suppose that would be our sample, and we'd be using that to estimate. But that doesn't seem to be the situation here. Mean number of cigarettes smoked. Well, it's mean, so it's quantitative from a random sample. So that's a statistic. This, of course, was a parameter here. And the mean is mu. Okay. All right, the mean household size of all household size is quantitative, so that's mu, and that's a parameter. And now, as if we've gone through some strange time warp, we get this overly detailed part D. The difference in proportion, who have ever smoked cigarettes, between a sample of 500 people who are 60 years old and a sample of 200 people who are 25 years old. All right, so this is talking about a sample, and we're going to use p hat minus p hat. So a sample of 500 who are 60 years old. So let's put a little subscript here and a little subscript here. And so we might use that kind of notation. That difference is the estimate of the population proportion for, getting at the difference in prevalence of smoking for these two different generations, really. And so this would be a statistic. Right? Okay, so I am going to go back to the notes here for this section. But I think this might be a good place to take stock just before I move on, because what I want to do is get into some of the issues of the sampling distribution. So that might make a good stopping place. But just before I do that, let's look at the idea of the parameter versus statistic. I'm introducing some notation here. I've introduced some of it already, but standard deviation, we use S before. Corresponding population value is the Greek letter sigma, corresponding to S, so that would be the population parameter. And for correlation, we use the Greek letter rho for the parameter and R for the correlation. Okay, so we use the statistic from sample as a point estimate of the corresponding population parameter. And then this is the section that we're going to get into next. So I'm going to pause and join you in part 2. Thanks for listening, and see you in the next one. Take care.